So in the previous videos we talked about, I started to introduce the notion of functional groups. And now I want to bring this a little bit more and talk a little bit about this a little bit more. Not so much in details of how those functional groups actually react when they're put with different compounds. The goal is not to do this. But this section is about creating macromolecules. And it's creating, if we remember, macromolecules are big molecules created from simple molecules, right? So I referred to this as Lego blocks before. So the small building blocks of macromolecules are called monomers. And then a macromolecule is known as to be as a polymer, right? So it's an assembly of smaller subunits attached together. And the attachment between the two subunits are covalent bond. So it's a very solid bond where electrons are shared between two different atoms when those two monomers are connected together. Now, I want to introduce a few of those small groups that are part of those small monomers, and those smaller groups might be involved in the creating of those bigger polymer or bigger molecules. Okay, so I just want to introduce the main players. I'm not even going to go through the entire list, but I want to bring some of those key players as functional groups because you are going to see them and you're going to hear about them. And I think at this point right now it's important that you are aware of what those functional groups are. And then we will look at two special functional groups that are implicated, that are part of creating macromolecules known as proteins. Okay, so that will be, and I will mention that. So what I want to show is the different types of functional groups, and I will start with this one here. So functional groups, often when you look in books or websites, they will be referred as to R, right? So R is for radical. I'm not sure exactly why that is, but R is, it would indicate that there is a functional group there. There is something there. There's a piece that we don't want to define at the moment, right? So what I'm going to do here is explain what those R can be in the case they would be functional groups. So I want to connect those functional group to a central atom of carbon. So I'm going to draw my atom of carbon here, and I'm going to show you a few of those functional groups. So whenever you see something like this one, when attached to a carbon, and you see COH, right? So what we have here is an hydroxyl group, hydroxyl group, right? Whenever you see something like this connected to a carbon, this is known as an alcohol group. Okay, so this COH here is known to be an alcohol group. If you ever see something like this one, C, and then you see C, and then on one side you see O, and then you see H here, that is known to be an aldehyde group, right? So aldehyde group. Whenever you see something like this, this is known as an aldehyde group. So as in formaldehyde, for example. So this part right here is aldehyde, this part right here is known to be alcohol. Now let's look at another one. I'm going to remove those here, and we're going to look at another type of very important group here. And this group attached it to a carbon, right? And then if we have something like this, O, and then OH, right? OOH is known to be as a carboxylic acid group. Carboxylic acid group, if you ever see this, that's what it is, a carboxylic acid group. very important functional group when we're talking about proteins. I will come back to this a little bit later. Now another one that is really important for the creation of macromolecules as in proteins is the next one right here. So we would have a carbon always, right? And then we have H. H here and H here. Okay? So this is known as an amine. Amine group. So the atom here is nitrogen, as you know. That's the atom right here, nitrogen, and this is connected to 2 hydrogen atoms right there. This is known as an amine group. You will also see amino group. It is possible that you encounter this when you read or look at websites and stuff like that, right? So you'll see amine or amino group, but the real name for it is an amine group. We say amino when it's incorporated in some other molecule. No need to get into this at the moment, okay? So these are 4 very important ones. I'm going to bring another one that is quite important, and then that'll be for the list today. So the other one is this, so our carbon again, right? And then if we have something like this, SH. So S here, the atom right here is sulfur. Sulfur. And then SH is known as a thiol. Thiol group. Right? So if you ever see thiol group, you're thinking, you need to think that there is sulfur in there. And you would know if you ever are in the vicinity close to a molecule that has a thiol in it. And if it's in vapor, you will feel that because it has a very interesting smell, right? Thiol and sulfur compounds are very, very strong smell to them. So that's what I wanted to bring today because I want to explain what proteins are, and I want to explain how proteins are made, right? So we will use those important functional groups. So when we're thinking about the building blocks of proteins, we're talking about amino acids, okay? So amino acids are extremely important. There's 20 of them in nature. Actually, there's a little bit more than that, but there's roughly 20 of those amino acids, different ones. So you could think of different kind of Legos, different colors, different sizes, and all of that, right? So you can build, sometimes to build a house, you need more than one type of Lego. You need all of the other ones. Some can go around corners. They're rounded in some way. So we need a variety, a diversity of amino acids, right? So one thing that I want to explain here is the basic structure of what an amino acid is. And this is super important. You need to memorize that. You need to know what an amino acid looks like. They all have a common structure. Almost, I shouldn't say all of them, but almost all of them have this one common structure. And this is where I want to get at to right now. So we are going to connect our amino acid to a central atom of carbon. Now, one thing that I haven't mentioned yet is that a carbon atom has the capacity, the possibility to create four bonds with other molecules around it. Okay? So when we look at the 3-dimensional structure of methane, if you remember well, right? Methane had this, had this little structure, right? So we had methane was the chemical formula is CH4. CH4, as we can see here. And then methane is connected to 4 atoms of hydrogen, right? So we have one here, we have one here. But remember that this is three-dimensional, so there's 3D. I have a board here. I don't have the capacity to bring this out and then manipulate it in space. So because I have a two-dimensional restriction here, what I'm going to do is I'm going to attempt to create this three-dimensional part. And then you'll see this in books sometimes. They do that as well. So what you have here is a link to another hydrogen atom. So what you have here, this little triangle, is supposed to be a projection. So you would imagine that this hydrogen is out here, not on the plane of that board right here. It's actually in front of that. And then at the back, what I would have here is another atom of hydrogen. But you see I have a dotted line here. The dotted line means it's behind this board here. So as if we didn't see it, right? So what we have here is this one, this one, this one on the plane here. And then one is sticking out and the other one is sticking in front of us. The other one is sticking behind the board right here. So that is methane here. So this here is the central carbon atom. 4 links. 1, 2, 3, and 4. Now, please remember that because when I draw the basic structure of amino acids, I will refer to this carbon right here. Okay? Now, I am not going to draw all of those projections. Now you know, I don't need to do this. You know that it's supposed to be in three dimension. We are restricted here because we were working in 2 dimensionals on the board, but I want you to remember that. Okay? So the basic structure of amino acids, they're basically always made the same as a carbon right here that's on the inside. And then we have a 4 lengths here, right? So we would have something like this. So we would have a group right here, and I'm going to draw a functional group here. And the functional group that I'm going to put here is NH2. Right? Remember what that is, right? That's an amine group, right? That's amine. But remember, we're talking about amino acids, right? Oh, well, there you go. That's the reason why. Okay? Now, NH2 here, remember that N, it's actually NHH, but I'm simplifying everything. So I'm condensing this as NH2 right here, okay? So that's why you have this here. And then what I would have right here is another one, and what I have here is another carbon, but then I have OH, right? So we know that this part here is our carboxylic acid group, right? So carboxylic acid. Carboxylic acid, okay? Amino acid, right? Amino acid. That's why they're called amino acids. And then right here, which we're not going to pay too much attention to, I'm going to write R. And remember that R is there so that we can explain, we can give anything, attribute anything to R here. So basically, is that when we don't want to draw a specific structure because it's not needed, we write R. And that R can be, in the case of amino acids, super simple. It can be quite, a little bit more complex. Not quite complex, but a little bit more complex, depending on the type of amino acids. Right now, I don't want to go there. I don't want to explain this here. But what I want to show is this, is that we have the structure of an amino acid, and I will refer to amino acids now on the board as AMAC, amino acids. And the reason for this, amino acid, and then we have our central atom of carbon here, and this carbon, just for your information, is known as the alpha carbon, the central carbon. And you could have other denominations for this, but that's alpha right here. So alpha alpha, like that. Carbon alpha, alpha carbon, right here in the middle here. Okay, so now you know what the basic structure of the amino acid is. Now we're going to play with this now, and we're going to see what we can do with this monomer and this little piece of construction block. Okay? Okay, my goal here is to explain how two amino acids can link together, two monomers can link together and form a dimer, right? The formation of a dimer is the beginning of the formation of a polymer. It needs to start somewhere, right? So this is what we're going to look at right now. The structures you see here, here, and here are two amino acids. So as you can tell here, I have amino acid number 1. I have amino acid number 2 right here. Each of those have an R1 and an R2. If the amino acids are the same, it is possible, right? Then I would have R1 and R1 here, and if they're different, then I have a different R that I have here. That's why I have R1 and R2, okay? So remember that I have amino acid number 1, number 2, but those two amino acids could be the same amino acid. What I want to illustrate here is the link between those two amino acids, how they get connected together, forming a covalent bond that will lead to the formation at some point of a protein, the polymer of what amino acids are. So this is my attempt here. So what I want to show here is that we have two amino acids that are coming close together. And when they get close together, it is possible that a chemical reaction will happen between those two, and that they will link together. They will start to connect with one another. Okay? So this is what I want to illustrate right now. Okay? So we have seen that there are different kinds of reactions, biochemical reaction. One of them is a reaction of condensation. When we have a reaction of condensation, we have two molecules that are reacting with one another, and they create a water molecule, right? That is what a condensation is. So this is what happens here when amino acids are linked with one another. Let's follow this, right? So what I have here is my amino group, right here, amine group. And on that side here, I have my acidic group, or carboxylic acid group, right? We've seen this before. We have seen what the functional groups can be. So now this is what we have here. I'm going to remove this here now that we know what those two groups are. I don't need this anymore. And what I want to do is link those. Since this is a condensation reaction, and I have an OH here and a nitrogen right there, right? What's going to happen is that when those two link together, this is going to create a water molecule. That is a condensation reaction. So we are going to lose those two atoms here, those two molecules here, creating water. So water will be expelled from the group, right? And then those two atoms here are going to get linked together. So you see this big fat link here? That is a covalent bond. So basically, the electrons are shared now between the nitrogen and the carbon atom on that side here. Okay? So if I can redraw this just to be a little bit cleaner, right? So what I have here is I have a carbon here, and then I do have here my nitrogen. And the link between those two here, let me draw this in another color. Let's use blue here, just to illustrate this so that it's easier, right? So I have this here, this blue link here, which is a covalent bond. And then on that side here, remember what I have left after water is being created, it's been expelled through the reaction, condensation reaction. Then what we have here is an NH. And then what I have here is a H as well, right? Right, sorry. Here's what I have here, right? So that is my link between those two amino acids. This type of covalent bond here has a very specific name. When two amino acids are connected with one another, this has a name, and that name is known to be a peptide bond. So when we have a string of two or more amino acids connected with one another, we no longer have amino acid number 1, number 2. We have a bigger molecule. And that bigger molecule, right, so we no longer have those two here. We don't consider them individually anymore. And we say that what we have here, this is known to be a peptide. A peptide, right? So peptide right here. And this link here is the peptide bond right there. One thing that I need to illustrate here, and you'll see this when we're talking about proteins a little bit later, is this. On one side, on that side of the peptide, where amino acid number 1 was, right? It's right here. It's no longer an amino acid. It's now part of a peptide, a bigger molecule. We have a side right here that still has the carboxylic acid. And then on that side here, I still have the amine group. So what do you think is going to happen if I bring a third amino acid on that side, or on that side, or a fourth on that side, right? We can repeat this same reaction here over and over. So from a dimer, we would go to a trimer, 3, and then 4, and then 5, and then 6. And then at some point, we can even have like thousands and thousands of those amino acids connected with one another. Now, since, and that's an important part of nomenclature we're going to look at right now, is that since we have on the one side a carboxylic acid piece of it, functional group, and on the other side we have the amino or amine functional group here, we would say that this peptide has two sides, right? It has two sides, like right and left, except we don't say right and left. What we say here is that because of this carboxylic acid group, we say this is the C side of that peptide, and then here, this is the N side of the peptide. N for nitrogen, of course, and C for carbon. So, dimer made of two amino acids. Those two amino acids have condensed, forming a peptide bond. This is now called a peptide. The peptide has two sides. One side is known to be C side for the carboxylic acid. The other one is known to be N side, the N side for the amine part functional group of that molecule.